Hello everyone, welcome to your channel Data Science Studio, and today we are starting a new series on statistics. And statistics is a very important if you want to transition your career into data science or data analytics industry, and it is a very important tool to understand the mathematics that happens behind the various algorithms in the different data sets. So let's get started. So statistics is very important if you are a data science, whether you are a data analyst or you are a data scientist or you are a ML engineer. If you are in and if you want to transition your career in any of these fields, then statistics is a very important subject, because without understanding the maths behind the algorithms or without understanding the basic concepts like descriptive statistics or inferential statistics, it is very difficult to infer a meaningful information from the data. So before we get started, we need to understand some of the basic functionality of what is statistics. So this is a definition which will give you very clear clarity on what we are going to study in statistics. So it is an both art and science of collecting, analyzing, presenting and interpreting findings from the data. So this point is very important. We are going to interpret the data which we have collected via various methods to generate insights for our clients. So for example, if we have a sales company and we are collecting a data for a product sales over a period of time, so we can study and say that how the product is moving, how the sales are happening over a period of time. Most of the weather agencies or temperature agencies, they collect over a period of time weather data and the temperature data to study the patterns in the atmosphere. So any kind of data collection, analyzing, presenting and interpreting findings from data is called as statistics. Now, first of all, we have to understand that what is a data. So data is nothing but it is a collection of observations for studying a variable, and a variable could be your weather, a variable could be your temperature. So a variable can be anything, and when you are collecting observations, and that observations should be in a organized format. For example, if you are collecting stock price trends over a period of 3 years, then it is a data. Now, when we are talking about data in statistics, there are two components which is very important. One is population and another one is sample. So most of the time it is not possible to collect data for a variable for everything in the population. So if you want to collect all the variables or observations for an experiment under study, so for example, let's say that in a city I want to calculate what is the average height of males. So I cannot go and study each and every, or I cannot go and study or collect each and every data about the height of the males in a particular city, because that is not possible. So that becomes your population. So the all the males in the city, all males in city will be your population. So since you are not going to collect each and every male data, it's not possible, it's costly also. So there's a concept called a sample. So we collect a sample out of it. So a sample is a subset of a population in which a statistical study is performed. So sample will always be a subset of a population. So now by now you should be very clear that what is statistics, what is data and what is population and what is sample. Now there are different kinds of statistics which we use most predominantly. There are two types. So one is your descriptive statistics and one is your inferential statistics. So most in our complete course we'll be talking about these two set of statistics. So in case of descriptive statistics, it is a branch of statistics that contains various methods to summarize and describe characteristics of a set of data by way of graphs and numeric measures. So here what we are trying to do is we are trying to summarize our data by way of graphs or numeric measures, and we'll see that what does that mean. So for example, if I want to create a bar chart, so bar chart will look something like this. And if I want to create a pie chart will look something like this. So it will have various percentages. So when I am presenting my data in the charts format or when I am presenting my data in the numeric format, it could be measures of central tendency or measure of dispersion, which we will be discussing in detail. So measure of central tendency, when we are calculating the numeric measures like mean, median and mode. So mean is the average, median is the middle value and mode is the most frequent value. So most frequent value in the data set is mean. So we'll be discussing in more detail in our subsequent sessions. Just to give you an idea, measure of dispersion actually talks about what is the spread of your data. So if your data is spread like this, then the variance will be very less. If your data is spread like this, then the variance will be more, because variance talk about how your data is distributed across the mean. If your data is far from the mean, then the variance will be more. If your data is close to the mean, then the variance will be less. And we have another component which is called as standard deviation, which we use most frequently in our day-to-day work in data science or data analytics industry. So this is from the perspective of descriptive statistics, when we use graph and numeric measures to interpret the characteristics of a set of data. And then we have something called as inferential statistics. In case of inferential statistics, we are actually trying to make inferences about the characteristics of a population based on sample findings. So as I told you, it is not possible to collect each and everything about the population because of various reasons: cost, complexity, time, and hence we take a subset of that population and we study the characteristics of the sample and make inferences about the population. So this point is very important. We infer what will be characteristics of the population. And in inferential statistics, there are two kind of methods. One is parametric, one is non-parametric. So for now, I'll not go into detail. We'll be going into detail in our subsequent sessions. But you should remember that descriptive statistics talks about the graphical and numeric measures, and inferential statistics talks about methods that are used to make inferences about the characteristics of a population. Now we'll talk about another important topic, which is types of data. So whenever we are going to our target population or the sample, we are collecting some data, and that data has certain forms. That data, for example, if I am collecting a gender specific information, whether a person is male or female, then we are actually collecting the a categorical data or a category. So male is one category, female is another category in which it can be grouped. And if I am asking some opinion, like do you know a particular language like Sanskrit, if it is yes or no, then also it is a category. So the first form of data is called as categorical data. When you have categories in your data, and most of the time it could be gender, it could be city you live in, it could be country you like, or the languages you know. All these are called as categorical data, which you can define into fixed set of categories. Another set of data is called as numerical. In case of numerical data, there are two types. One is discrete, another one is continuous. So in case of discrete data can be counted and take only certain values. For example, if I am talking about number of players in a cricket team, so number of players in a cricket team can be 11. It cannot be 11.5. It cannot be decimal. So it can take only certain values and it can be counted. It should be kind of a whole number. So this is discrete data. So number of players in a team, number of cities in India. These all examples are of numerical data. Now when we talk about continuous data, so this is also a very important data type, and we use most of the time we work with categorical data or continuous data. So continuous data can take any numerical value. It can take 11, it can take 11.5, it can take minus 11.5. So it can take any numerical value, for example height, weight, etc. So height and weight can be decimal and it can be a whole number as well. So this is from the perspective of the different kinds of data. Now next is, whenever you are collecting your data, you are collecting in a certain format, which we call it as a measurement, scale of measurement. So what is this scale of measurement? Says that whenever you are going to collect your data, what is the scale or how you are going to explain your data. So in terms of scales of measurement, there are predominantly four kinds of scales. One is your nominal, then ordinal, then interval, and then ratio. So nominal and ordinal, in our previous slide we have seen that we have categorical and numerical. Similarly, in terms of scale of measurement, when your data type is categorical, we normally go for nominal data or the ordinal data. And when your data type is numerical, we go for interval data or ratio data. So when we are talking about nominal data, you cannot compare the categories. For example, there is no order or rank for the variable under study. So if I am talking about the city where a person lives in, so if the city is Chennai or the city is Lucknow, so these two are different cities, these two are like categorical data. So there is no ranking and there is no order. I cannot say that one city is bigger than another city, or one city is important than another city. It is just the place where you live in. So in the nominal data, there is no order or rank for the variable under study. So in this case, it is a nominal data, because I cannot provide a ranking to my category or a order. But in case of ordinal data, order is present for the variable under study. So, for example, you can have components like very dissatisfied. So, as we discussed, in case of ordinal data, there is a order associated with the variable under study. So, for example, I can take the opinion of a person for a particular product or a service, and it can rank order it based on very dissatisfied, satisfied, or neutral, or satisfied or very satisfied. So in ordinal data, it is also for the categorical data, but it has a order associated with the variable under study. Now when we talk about interval data and ratio data, they are used basically for numerical data. And now in case of interval data, the interval is an important word. So for example, let's say I am studying a credit card score of a person, and if I say that the difference between 200 and 300 score and the difference between 400 and 500 score is 100, and which is equal. So when I say that the interval between observations is fixed, so here I have two observations for a given person, and here I have another two observations for a given person. So the interval between observations is fixed and the same, and 0 point is not meaningful. For example, I cannot have a credit card score of 0. It will always be some number. So in case of interval scale, the 0 is not meaningful. So I don't have a absolute 0. So 0 is not meaningful in case of interval data. But in case of ratio data, we have a absolute 0 as well. So for example, in addition to the properties of interval scale, the ratio scale has the absolute 0 as well. So for example, if you have height, if you have weight, or if you talk about how many shops you have in the area, it can also be 0 shops, it can be 10 shops, it can be 20 shops. So whenever, and I can compare my height with respect to the 0. So I can have 5 feet, I can have 6 feet. So in case of, the only difference between interval and ratio scale data is that in ratio scale we have a absolute 0, and the data also has magnitude. It can be compared with respect to the 0. However, in interval scale, it does not have a meaningful 0. So but the difference between the two intervals for a variable is equal. Next session we will be talking about what are the different sources of data, what is the different classification of data. So sources of data like primary or secondary, and then we'll talk about measures of central tendency and measure of dispersion. So every session we try to correlate what we have studied in past. So measure of central tendency and measure of dispersion, these are your concepts of descriptive statistics. And whenever you are trying to collect your data for your study, you are going to different sources, because you have to go to different sources and collect your data, and we'll be studying in detail about primary and secondary sources. So we'll be having multiple sessions, and we will try to make sure that you understand all the concepts of statistics thoroughly. So please like, subscribe, and comment on your channel and provide your valuable feedback, and we will be posting the session 2 shortly.